for last week, we discussed this one, right? So in optimization problems, we need to understood the problem complexity. How complex is your problem, so that later on you can select which solution approach work best for your problems. Okay, so you can always see again the video, the previous video. I already put it on YouTube. And well, basically, how complex is your problems? It really depends. It can be shown from the in which category your problem belongs to. Okay, last time we discussed about how do you categorize this problem, right? We have terminology called big O notation to show the how the performance of algorithms on solving some problems, and based those algorithm classification, we can find if your problem have such algorithms that can solve it until optimal in a polynomial times notations that represent by those big O notation, then you can consider that problem is an easy type of problems. It doesn't reflect that it is easy in the field or something, but in terms of algorithms approaches that available, it is can be solved until optimality. That's how they consider easy here. And then you also have another category of problems that belong to medium problems that normally in between those category, they part of it perhaps can be solved until optimality, which rather fast, but part of it maybe not. Then the approach that we discussed earlier in the first meeting until I think, if I'm not mistaken, the 5th meetings, in which we are utilizing mathematical programming approach, where mathematical programming has a solver, a mathematical programming solver that embed exact algorithms inside of it, would not work for this type of problems. Okay, for the problems that belong to category hard, not to mention the hard, the harder part, which is NP complete and NP hard, perhaps those approach that we study using, that we use previously, in which using mathematical programmings and calling their solvers, it might not work for, especially for larger size, larger problem size. Okay, that's why we need to how to say, to learn different techniques, different solution methods. Yeah, here this slide show you that there are a lot of solution methods that you can use, in which for last week we learned one type of solution methods called rule-based method, in which we try to embed a rule-based an approach that is belong to heuristic, perhaps can be categorized as heuristics. Rule-based, heuristic, and meta-heuristic all is belong to one category, in which we are not trying to find the optimal solution. We are satisfied enough with the solution that works. Yeah? Optimization problem have objective, have the constraint, and then rule-based, or the category of approximation, doesn't really, because we realize that some problems is hard to solve. You can't even find a good solution if you push, if you resist, if you insist to use exact solution. Okay, that's why we for those type of problem, and then when the size is large, we are considering to use a less with a trade-off of less solution quality. You try to use rule-based or heuristics or meta-heuristics. Okay, last week we learned rule-based. in which here both of the all of this method we have the description about how it compare one to another in terms of solution quality. Okay, you can see the video again. It is available on YouTube. Yeah, and then this is all okay. Rule based, it is normally associated to the problem. Why? Because yeah, every problem has their own approach to get the solution, right? And moreover, if you want to use a rule base, so the rule will be really specific to the problem characteristics. Okay. We discussed several types of problems like facility location problems, there is model in covering problems, center problems, p-median problems, TSP and VRP. Each of those problems has their rule-based approach, and it is so many. There are so many of it. Okay, and here I will try to give you one example in which we will try to solve a type of variants of covering problems, and then we will really implement it on because rule based is an algorithms to the way to implement algorithms is you need to code it. Yeah, it's a little bit different with mathematical model. You need to translate it or into a mathematical programming language like Lingo or AMPL or Cplex. But for this one, what you need to do is actually code it into using any programming language. Okay, or you can use Excel and then calculate it manually. That's also possible, but I would not suggest that one, since normally you move to rule based because the problem size is already large, so you need some help to do it. Yeah, then you need to yeah, I think utilize programming language. Later I will show you, but this is not the only way to implement it. So you can learn another approach as well. But I hope this can give you a little bit of introduction on how we can do it actually. Okay, go back to the problem first. So because before we implement the code, before we implement the rules to solve this problem, we really need to understand again the problems. Okay, this is yeah, we discussed this several times already. Maximum covering location problem, where we want to find a set of location that covered that covered the most demand possible out of limited number of facility that we able to utilize. Okay, so the problem is like this: we are given a set of customer demand that is ready to be served, and then however, in terms of if we want to serve this demand, we need to select several facility and then connected those facility with that demand. So we consider that this demand will be covered by that facility that we are going to select as a decision variable. Okay, and then but in terms of number of facility can be selected, we have limited number of facility can be selected. Okay, the number is defined as P here. You can only select P number of facility. So if you given only select, let's say P equal 1, it means that you can only select one facility that maximize the total demand coverage. Okay, and demand coverage is represented by the one parameter called covered distance. Let's say if the facility, the distance between facility and one particular customer less than, let's say, for example, 10 kilometer, then you doesn't consider that one as a covering. That facility can cover that demand, something like that. And then we translate those into some data called adjacent metric here, AIJ. And you can always go back to the definition because this is just a rough definition that I try to explain to you to give you a little bit of memory refreshment. Okay, an example of these problems, perhaps you can see in the screen, it looks like this. Wait, okay, yeah. I hope it doesn't. Okay, Okay, let's say we have A, B, C, D, E, F. Demand point need to be covered. Okay, and then you are asked to, okay, among this point A until F, please help me select one facility that will cover the most demand. This one, P equal to 1. Okay, and then maybe utilize some writing a little bit. Okay, yeah. P equal to 1, and then another parameter that we need to know also is that my mouse doesn't work. Okay. Okay, sorry for the technicality. Okay, here you go. Okay, this one P equal 1, it means you are asked to open one facility. If this one become 2, then you ask to open 2 facility. Okay, and DC is the distance coverage. It's equal 11. It means that you will consider one facility is covered by another facility if the distance is less than 11. For example, if you select, okay, I will select A as the facility that I want to open. It means that if you select A here, the facility is here, it means that you can check which other nodes have distance less than 11. So for example, A to B is 8, so this one. If you open A, means you already covered B. If you open A, this one, 10 less than 11, you already covered D. That is the use of this coverage distance parameters. So it means that the objective value for this one, if you open A, it means that it will cover A, B, and D, but not C because it's more than 10. So you can only the objective function for when you open an A as a facility, the total demand being covered is 10 plus 8 and then plus 18. So it's 36. Yeah, the total demand if you select A is 36. It's different case if you open F. F, you check only covered itself, right? 1, 2, 3. F is not covered E, not covered C, not covered D. All is more than 11. But the demand in F is 15. Okay. So if you compare, actually, opening F give you more. This one not minimized. This one maximized. Give you a more amount of demand being total demand covered. Okay. Yeah. That's how that's the decision variables and then the interplay with the objective function. Okay, now I assume that you already know this problem. It is in the assignment as well. So now, okay, for this type of problem, it is actually belong to NP complete, and it means that for well, of course, for small size instances, like only six nodes here, it will not really it will be preferable if you are using exact approach, because it can solve the approach can solve these problems until optimality, because it's still small size problems. However, when you increase the number of the nodes, make the problems more complex, all nodes is connected to each other, perhaps it will be more and more difficult to solve using exact solution approach like mathematical programming or others exact solution approach. So for that case, you need to utilize another way, right? And here I introduce you to a one type of approximation approach, so-called, last week I already introduced this one. It's called greedy algorithms, in particular for maximum coverage location problems. This greedy algorithms has complete name of greedy adding algorithm. So the basic way of thinking of this greedy algorithms is like this. Whenever you want to select a facility that you are going to open, okay, you will always try to select the facility that give you the most demand cover. Okay. Okay, that's the basic thinking of greedy algorithm for this one. In that case, it means what? It means that when you only able to select one, p equal to 1, so you just select the most, out of all those facility that is not yet selected, find the one that have the most demand covered. Okay, it's easy for p equal to 1. But for more than one, you need to continue the greedy philosophy embedded in the algorithm, right? So first, okay, here's the step. Okay. So whenever you have more than one facility, then you can utilize this approach. We will first find out of the facility that is not yet being covered. Okay, for the first time, all is not yet covered because we don't select any facility yet. And then you select which one have the most demand covered. It's play well with the philosophy that we discussed earlier. And then, okay, I will select those facility, and then I will consider all the demand that is covered by that facility that I select will be already covered by that particular facility. For example, previously, if I select A, I will have B and C covered. Sorry, B and D covered, but not C. Okay. And then, okay, this is only for one facility, one particular facility. Now, here is the tweak that we made. Okay, now if I have a chance, or I am allowed to have more than one facility, perhaps. Okay, let's say if I have 2, I have 3. Of course, first I will check if all the demand already covered, it's no use to open more facility. But if not all the demand being covered yet, yeah, for example, if I open A, I only cover A, B, and C. What about the rest? Okay, we need to check, can I open more, right? If I can open more, which one should I open? Okay, so first, if already covered, then finish. No use to continue the algorithms. But if not, you go to the same process again. This is how we implement algorithms. Go to the same process. Okay, out of the one that already covered, so A, C, B, take this one out. Okay, here they take it out here. Yeah, it already taken out here. A, B, D already taken out. So you only have D or E or F. Which one you will select? Okay. Based on greedy rules, I need to find among among C, D, and E, which one have the most demand covered. Okay, then I will select that one. Okay, after that, I remove the one that already covered by the particular facility that I open. And then what? And then I check again. Is it all the demand being covered already? If not, continue again, ask, can I open more facility? If not, if you cannot open more, then you finish. If all the demand already being selected, then you finish. Yeah, that's how the algorithm works. Okay, and then let me show you the example. Okay, we have this one. Okay, let's go start one by one from this example. Okay, first start, find the, okay, let's try to experiment with covered distance is equal 11. No, this one DC is 11. This one is equal 3. So you are allowed to open 3 facility among this one. Okay, what should you do? Okay, first find the site that cover the most uncovered demand. This one. Okay. So what you need to make this table. You need to list all the candidate I have. Which one is not yet which one is not yet being used, right? So I have A, B, C, D, E, F. All is not selected yet. Sorry, why I used 9 here? Okay, let's see whether I use 9 or 11. I a little bit forgot. I think it should be 11. No, it's 9. It's 9. Sorry, 9. Okay. Wait. If 9, A and D is D. Yeah, it's 9. Okay, 9 covered. So let's say if it is 9, the covered distance. When you open, you have candidate facility A. It means that if I want to open in A, I will check. Okay, I have A because A to A is 0. Yeah, open A, you got the demand at A. And what other facility can I cover? Check the coverage distance. 10 doesn't cover. 8, okay, covered. So A and B. 15 not covered. So A and B. Candidate facility at A will cover node A and B, which means that you have the demand of 10 in A and then demand of 8 in B. So the total covered demand is 18. Okay, let's try one more example. I try to open, I select B. Okay, let's say B here. B, this is B. So the demand covered, I check the distance, coverage distance. Okay, 8, okay, covered. So I got 8. 12 doesn't cover, 16 doesn't cover, 7, okay, 7 is good. So you have A, B, and D. A, B, and D. So you have 8, so you have 18, so you have 10. The total of it is 36. Yeah, that's how you calculate the table. Then you need to populate all the table, and then you can see that we want to what? To select the facility that has the most uncovered demand. So out of this one, as you can see here, the most uncovered demand will be covered by F. Okay, that means that we can select and locate F as the facility that we are going to open for the first time. Okay, based on these rules. Next, after that, you say F, and then you can go to the next again. The third step here, you can see, okay, now I need to remove. Okay, previously we have F here, right? F here. Which node is connected to F? Only itself, because other is less than 9. Yeah. So the next step is remove all demand covered by the most recent cited facility. So remove all demand related to F. So it means, yeah, only itself. So you can see here, F is being removed. Okay. Now you need to go to the next step. What should you do? Is it all demand already covered? No, we still have many. A not yet covered, B not yet, D, C, E, all is not yet covered. Only F is just covered because we open one facility at F. So what should we do next? Okay, you should ask, according to algorithms, these algorithms, can I open more P? Can I open more facility? How many facility you have? P equals to 3. You open only 1 now, right? So you still have you can still open 2 more facility, right? So how do you select among those facility? Okay, yeah, how do you select? Yeah, fine, again, calculate again this table. A is 18, B is 36, C is 29, D, E. Okay, now I know I should select B. I open B and then I see, okay, B, what should you do next? Okay, I open at B and then next, remove all the demand covered by B. So which one is it? B, A, D. So the next iteration, you will only consider C and E. Okay. Okay, C and E, and then you go to the next iteration, C again. Is it all the demand already covered? So no, C and E is not yet covered. Can I open one more facility? Yeah, if we check, with the number of facility being open now is only 2. You can still have one more, right? Sorry. So you can still have one more. So you can go to the same iteration, same process, but for now you have the same total demand. How do you select out of this? Yeah, just select either way is okay. Okay, and then you allocate to that facility, and then okay, what you do next? Remove all the nodes being covered by C. Oh, this one actually remove all of it. So at the end of this iteration, you open 3 facility and there is no demand left uncovered. So when it's go to this iteration, and then when we ask the question that we always ask at the end of this process, is it all the demand covered? Yes. If already yes, then you just go here. Okay, then it's finished. That is how do you illustrate the greedy algorithms. Okay, well, actually, I'm really sorry that I couldn't finish the code for Python. I shouldn't promise you that, because I just start installing all my Python IDE and stuff, and I have no time to recode this one to the Python version. But anyway, for you that already understood Python, you can always translate this one to Python. But if you are not yet learning any programming language, it's always good way to start. You can start from Python, you can start from C#, the one that I use here. You can use any other programming language. It's all up to you. And either way, it's work the same way. You should code it. After you understood that one, you can code it and implement it like this. Okay, I will try to re-implement this one. Hopefully, it will not too boring for you. If you are not familiar with programming language, maybe I will slip a little bit the explanation here and there. But again, I will always encourage you to take any course about programming or short tutorial in YouTube. I think for like this learning the basic like this, it will not take too much time. You just need to learn the syntax. How do you do the variable definition? How do you do the how do you implement the input and output, print, and then procedure, looping, and those stuff. Okay. For this one, you can always copy this. You can. This is an online IDE. You can just open it, the link that I've sent you through the slides, and then you can copy this one, or you can run it online also fine. Okay, this will show you this program will show you the output of those algorithms. Okay, for example, we have this data. Okay, this data is the same way actually with what we have in the AMPL code. I just take out all those not necessary additional explanation about the data. And then here you see, after I read the data, all the distance and stuff, and then here you can see the facility is selected 3, and then we have facility B, C, and F. It's exactly what we already have in the example. Okay. Now I will try to, I don't really like coding here online because there is no debugging, and then there is no, I'm more familiar with using this IDE. IDE is integrated development environment. It's a software that you can use to code. Okay, I will recommend you for C#. You can use this one. There is IDE called Visual Studio, and it available almost for all the devices now. Previously, it's specific for Windows, but start from, I think, few years ago already, they provide for Mac, for Linux and stuff. So I think it's a good one, and it's free. There is a premium version of it, like for the professional, but I think the community version already quite powerful, and then adequate for what we need. Okay, this one, community. But I guess also there is new one will be launched soon for 2022. Just oh yeah, this one, 2022 download. Yeah, you can use that one. I think I still use the 2019. Okay, so that's okay. After the installation process also easy, just next, and then you will get to this. Let me show you okay, this one. You see, I still use the 2019. And then here, it's the first time when you open it, it looks like this. And for you that if you are using C#, you can use, okay, to create a new project, to start coding, you can create new project. And then for that one, actually, it's only console application. It just show you, it doesn't really fancy that have UI or something, but they are very powerful. You can do it to make website, mobile apps, and many things. But let's start from the basic first. We just want to create a console application using C#. But if you're using Python, it's also visible here, Python. But I think if you have other IDE that you're already familiar with, that's also fine. Okay, if you want to use C++, also fine here. I think many language also support it, but most of the use for this one is for C++ and C#, I guess. Okay, next, console application. Then select next. Then you can give the name. Let's say I want to implement the greedy adding algorithm. Okay, and here's the repo. I need to make sure that not forgetting where I put this. So I just I create new in our course, VS example, VS live code, to make it different with the one that I already implement. So put it here. Okay, greedy adding algorithms, the solution in greedy algorithms, it's fine. Then you should next, and then this one also no need, just use the default. Next, create. Okay, and Visual Studio is a little bit heavy on the memory load, so you need to make sure whether your system is capable to run this software or not. Okay, next, after finish, it will lead you to this display. So by default, it already give you like a hello world type of command. So when you start the programs, it will already display to you the like the hello world message like this. Let me wait for a bit. Maybe it's not yet appear. Okay. Yeah. Here you go. Yeah. Hello world, and then here is just the programs. and then it will close if you press other key after finish. Okay. Okay, or you can close it directly also fine. Okay, here there is how many part of the windows. Here on the right side you will have the we call Solution Explorer, where you can see all the files that you create. Here for C#, the default program for console application using Visual Studio, they will create it for you a program a file called programs.cs. CS is the extension for C#. For C++, they will put CPP, something like that. And then this dependency, you don't need to care about it. It's just the DLL that is needed for this one. And then here, okay, our main program for this a simple example, only one, using the program.cs, and your all of your code will start from this one, the main function. Okay, the main function, there is a function have the name called main. Your program will start here. It means that the first time you run the algorithm using this running button, they will go to this line and then go to the next line after this, and after they have this, something like that. It's how they works here. Okay, so then what should I do? Something like that. We want to implement the greedy algorithm, right? So let's go back again to see the slides. How do we implement greedy algorithms? Yeah, you can see here. Let's go back to the flowchart. Okay, there is actually 3 steps here, right? 1, 2, 3. Find the candidate with the most covered demand, locate it there, remove all the demands covered by that facility, and then check whether it can repeat this process. Okay. Okay, but normally we also need to think if you do programming, it means you also need to consider that you need to know what is the input, what is the process, and then what is the output that you want. Okay, so okay, like this, right? So in this one, let me explain to you. We will have input file. Okay, input file. Sorry, why it's too big? Yeah. Okay. Input file, and then we will have the program itself, the process in which we will process that input file using greedy aiding algorithms, and then we have the output file. Okay, the output of the process, which is which facility going to be selected, right? So that's the way you need to define first before you start your code. Okay, you will have sorry, input, process, and output. Okay, input, process, and output. Okay, the input here, let me show you. Okay, if you see the code, the example that I give in the link, okay, let me load it again. Okay, here you go. Here is the example. All right, so you can see there is a file here, .txt file, here. Okay, if you remember, what is this actually? Yeah, this is actually, if you can remember, the file AMPL file about maximum covering demand. This is the data file actually. This one. If you do the AMPL file, you can remember that. Okay, I have set I is the number of the facility. I have A, B, C, D, E. J is the number of the demand, A, B, C, D, E, F, A, B, C, D, E, F, and the number of it is 6. So I put here 6. 6 facilities, 6 demand, and then this will be what? 3 will be this one. But for the ample, last time we used only 1, right? We need to change this one to become 3 to fit with this the problem that we are solving right now. Here 3 is the number of the facility, and then 9, what is 9? 9 is the demand coverage. Okay, for the ample we translate it directly to this one, right? 1 means it is covered, 0 means it's not covered. So for this one, we don't really convert it directly here, but we will convert it later in the code. So whenever you have this one, the distance matrix, if it is less than 9, you will convert it become 1. For example, 0 A to A is 1. So this will come from converting this one to 0, 1 metric based on the covered distance. Yeah. Why do I put this one like this? Because the covered distance matrix will be depends, right? If you increase this one, if you I think 10 kilo is still feasible to be covered by the facility. So when you increase this table will changing, right? Sorry, this table will changing, the AIJ. But this table not changing. This table is fixed. It's a travel distance. So I put it like this, so to make it easier to be processed. But for ample, they don't have, they have those mechanisms. I just not familiar with it. So I directly put like this. Okay, then we have the demand data. I embedded here with their names, A, B, C, D, E, F. So A have demand 10, A, B have demand 8, C have demand 22. It's according to this one. And then this one, just the naming of the facility. Yeah. So this is our input. This is our input, okay, this data, okay. And then to make this one as an input, so we need to copy this one, and then where should I put it here? Okay, I need to put it in the same folder with the executable file that I will create for this one. So let's say the folder of these programs will be in this, sorry, here, right? And then this is the code itself, but this code will be executed using this one. We will have the executable file here. So you need to put the file here. Okay, let's say you name it MCLP1. Okay, to just naming. Okay, you put it here, save. This is the process, the input that you need to read, and then you process here. Okay, input already okay, and then process. The process where is here. Process the programs that we want to create. Okay, that is the process. And then what is the output? The output is the result. For example, if you see later, we want to give them the output like this. The total that is selected is what, and then what? This is the output. We will not create another file. Actually, it's possible to create another file, but for this one, we just want to display to the user. Okay, that is the first thing you need to do before coding. You need to know what is the input, process, output. Okay, now we do that one by one. First, reading the input. How do we read this one? Yeah, this is another file separated from our programs to be included here. Okay, okay. First, to do the programming language to save a data. So it means that you have a data here, right? This one. To process this data in your programs, you need to save it in variables. Okay, so now I will introduce you. There is a terminology called variables in the programming. Okay, for C#, all is, if you are using only one file, actually it is object-oriented based programming, but that's why it has class, it has function directly. But it's practically similar with others as well. But for this one, if you want to introduce the variables, you can use it as a public, and then public variables, or local variables that only known in the function. Okay, for me, my approach is, because I will separate into several function. Okay, several function. This is a function. Okay, function is a chunk of code that you collect together, then you just later need to select this name to call to use those the code inside that function. So because I will separate it into several function, I normally use a public, and then because this one only using one file, I will using static variables to save those data. Okay, first let me name it. Okay, this one is a comment for in C#. You will not run it this line of code if they have this sign in front of the code, or if you have this one, it's also the same. It's a no, it's not comment. The comment is this one. Another one is like this. Yeah, this one, this, and like this. That is a comment. Okay, but I normally use only one line code, a one line comment. So I use this one. I put the main variables, main model variables here. What is main model variables? If you remember again, we have, if we have the models, right? What is the okay, it's different. The variables here is to decide to change, but for variables in programming, it means that the data, the place you save the data. Okay, that's another different things that you need to consider. Okay, here we will have what, like, okay, the candidate facility, the demand, the number of facility can be open, the and stuff. Okay, and it is all in the input file that we will read later. Okay, and then so here we need to map one by one. Okay, let's say, yeah, this one, right? So maybe put it like this, so we have a side by side view. Sorry, too much. Okay. Yeah. First, maybe I will have okay, main model variables. So I will have the number of customer. Okay, public static integer I. Okay, this will save what? Save the number of customer node I. Okay, so you have 6 here, for example, 6, and then I will save what else? Static for integer J. Okay, what is static, what is integer, what is public here? Okay, actually you can read it on later when you study about programming, basic programming in C#, but for short I can explain that this is just a keyword. Okay, this 1 2 3 here, and then get set is just a keyword that you need to bear with it, because you are using C#. If you are using Python, you will not no need to define any of this. But for C#, they want to be more clear that, okay, this variable is public. It means that when you have another class or another files that want to access these variables, that they are allowed to access that one. But if you use this one as a private, So another class will not able to access this class, this variable inside the class. That's a long story if I need to explain that one. Static is the same way also. Static is like, because you are using same one file here, you don't really here in object oriented, we need to for the C#, they need to instantiate the object. Okay, you need to put new keyword and stuff. It's a long story to explain, but because I don't want to do that, I want to make it simple, I just put it here, public and static. And then integer, now integer is an important thing that you need to understood. It like for a programming language, conventional programming language like C#, C++, Java, yeah, and many those earlier than Python, not really earlier. I mean, like several programming languages want us to specify what data types. So this one you need to understand data types. What data types can be saved or can be stored in your variables? Okay. For example, here this is the name of the variables. I for what? I for saving the number of customer. It will be a number like this, and it is going to be an integer number. So you use integer here. Later on, if you want to save like this one, for example, the distance, it doesn't always 8, can be 8.2, something like that, right? So you can use another data types like maybe double or float, something like that, for saving variables or storing variables that is have the data type of real number. Okay, yeah, that is data type. And get set is just another C# thing. You need to read it by yourself. I think for short, I will just use like this. Okay, I think it's already explained it to you in more clear way already. And then what else we need to save from the file is the this one, the number of maybe the facility going to be located, P. Yeah, right? P. Okay. Number of facility to be located, P. And then static, this one. Here, the next one is a little bit tricky. If we have this, this one first, DC, distance coverage. Maybe I copy to make it faster a little bit. My typing skills not that good as well. Okay, here, DC, I have distance coverage and sorry. Okay, DC distance coverage or coverage distance, this one, 9. And then the next one is a little bit tricky because here we have two types like this. This is the name of the customer. This is the demand in that customer. The name will be another data type. It is string perhaps or characters. This one will be can be double actually for because sometimes the demand is not integer, pure integer like this. Okay, so what should I do? I can have coded like this. Okay, customer 1, customer 2, like this one, variable. Each one have variable, but that's not effective. So later when you learn programming, you need to have a better data type to solve this one. Okay, for this one you can use an array, okay, or you can use a list. Okay, an array is basically data type to store variables with the same data types. using only single or the same identifier. Okay, for example, I want to save this one, and a list is actually a dynamic type of array. So for example, if you want to save this one, the demand, the amount of demand, all is double, right? All is can be 10.0, 8.0, 2.2, 2.2 or 2.0, something like that. So you need to use a list. The way you can create list in C# is this one still the same, public static. This will be a list. Okay, sorry, not like this, list. Okay, and then the data type of list is double, and then the name is distance, sorry, demand. Okay, this will be saving a list of demand I. Okay, there is an error here. You can see that because we need to use the header of collection, system collection, because this list is need this using or header for to be able to be used in the C#. Okay, now you have the list already, and then okay, that one is one-dimensional array or one-dimensional dynamic array, so it's called list. And then for another one is we need to save the name as well here, the A, B, C, D, E, F. So here I already copy it. Also for this one, A, B, C, D, E, F, for the facility, I already prepared it for you. So you just need to copy it here. Okay, and then this one already we have. Okay, it's already have the place to store here. And then what about this one? This a little bit tricky again, because it's, yeah, first maybe you think, okay, just save this one by one, right? Like list perhaps, like the demand that you do here. But it is more effective or efficient if you use actually two-dimensional array, because this one is like from what to what place to another what place, right? So here, to use the two-dimensional array, you can use like this syntax, like this. Let me show you. Again, public static. This type the prop. Okay. Static, and then okay, now the array will be double because distance could be in term of a real number, and then you put two-dimensional array in C# by put like a square bracket here, and then in the middle, if you want two-dimensional, you put one comma inside of it. If you want to have three-dimensional array, just put another comma. Okay. I know it's a little bit troublesome for you that not yet learning this programming language, but I think this is just an introduction. I will not ask you to really into this for now, but I want to show you to let you know that okay, this is how normally how we can do it. You can do it another way, more efficient perhaps, but this is just one way that you may able to follow later. Okay, this one is distance, two-dimensional array. Okay, distance metric from node I to node J. And then later on, we will convert this one to covered this one adjacent matrix to show whether this this node is covered by this facility or not. Okay, a 1 and 0 matrix that represent whether a facility can cover a node or not based on their distance metric and covered distance. Okay, yeah, this one. So I need to have another an array like this, like the distance, but it is a 1 0. The value will be 1 0. No, this one again, sorry, copy the wrong code. we call it covered matrix, okay, like this. And the data type is integer. It will show you whether a node I is covered from node J or not. If it's covered, it is equal to 1, but if it is not, it will equals to 0. And how do you decide whether it's covered or not? We check their distance. Distance I from J, if it is less than the coverage distance, this one, the coverage distance, so it will be equal to 1. But if not, it will be equal to 0. How do we implement it? In the later when we process the data, that is belong to processing. Okay, that is belong to processing. This one just to process the input. Okay, to make this input can go in here, something like that. From this file go to this data that we are going to store. Okay, other than that, we have later we will introduce another variables for the processing. But I think I will introduce you later. Calculated variables. Okay. Okay, for now, I will do the first step. Read from here, put it here. Okay. Okay. So for doing that, I need to modify this code a little bit. Okay. The first step that I am going to do is read data for, we call it maximum coverage location problem. Okay, so I create another function called read data. Okay, since we already put the file name here, MCLP, in the correct folder, so you don't need to put the complete address. You just need to type it mclp1.txt. So you will read from this one, this file, go here. But this is just a empty function for now. For example, that I implement this one. Okay, here you go. It is an empty function. It doesn't do anything yet. So to let it do something, which what we want to read this data, so save it here. We need to provide them with instruction. Okay. So here I change it to file name. Okay, to read the data, actually it's easy. You first just, the syntax is actually just like this. You have the file name here already, right? So we need to store all this line first. So C# will read it. All will be converted to a string first. String. The string, and all the lines will be save it using this one, system.io.file.read all files, read all lines, and then where does that lines coming from? Add file name. Okay, that's it. Now you already read all the data here. Put it in your program. Sorry, wrong bracket. Yeah, this one. Only one line of code. Okay. But you just read it, not yet store it in the variables here. You just read but not store it. Okay. How do I know that? Okay, let me show you. For example, we have many lines here, right? Later on, you will learn a looping called for each if you learn more detail in the programming language. You want to see all the lines inside that variables lines. Okay, I want to print it one by one by using console.writeLine. All the lines here. Okay, what does it do? Actually, I will print this one by one again. Okay, one print until all the data is how to say, save it here. Okay, let me show you the step by step. We can use the debugging function here by put this breakpoint here, and then we see go here and see another breakpoint, and then we see how they print the file one by one here. Okay, to do that, you just click the same yellow green button here, and then it will stop at the exact breakpoint that we want them to stop. Okay, yeah. Yes, you can see that it is highlighted with yellow. See, go here. It doesn't print again the hello world that we have earlier, but now it stopped here to wait for us, give them instruction to go to the next process. Okay, how do I do that? You can use this one. Press continue. After this, it will go where? Go to this read data function. Which one is read data function? It's here. So you move directly to read data function, and then because there is no breakpoint here, so you directly go to the line number 27 here when we put the breakpoint. For example, here if I press continue, it will directly go to this line. You can see at first there is nothing saved in this line here. You can see it's null, and then the file name is already correct. And then if I continue here, let's say I put another breakpoint, you can click continue, or you can click actually the shortcut for this one is F5. Yeah, okay, like this. You can see that there is actually 22 lines here. You can see lines 0, 1, 2, 3, 4, 5, 6. This is a character that perhaps here we cannot see it, but there is a character here represented by \t, means for saving tab. /tab is this one. Yeah, that's why it's look like this. But basically this, all of this is actually the same with here. Okay, so if you want to see it one by one, you just need to run through the code, and then you can see that they will work like okay, yeah, okay, yeah. Here, if I press F5 again, it will continue the code, right? Here, okay, now I'm on the first line, line number 6. After I press F5 here, it will go up to the for each reach because we are not yet finished all the lines. So here you go. See, here they print directly 6 here. And then if you go again, print all the line one by one along the way with I press F6. Okay, so what do we got here? We already able to read from this data and then print it using our programs. But that's not enough. We want what we want actually put it the data here, save the data here. So please bear with me. I will try to explain it to you. Just this one in detail. Later on will be not really as much detail as this one. Okay. For this one, okay, you need another variables perhaps to help you give some explanation about this. I already create the code, like you see, we already have this code, right? So I read the data here, and then I will finish read the data here. Okay, the first thing I want to do is that I want to have the index first. Okay, the index, so that I have easier way to separate. Okay, this is line 1, line 2, line 3. Line 1 I will save it in I, line 2 I will save it in J, line 3 will be in P, something like that. Okay, so I put a line here, an I to represent it, and then I will always increment those I here in the loop, and then I will create I will read it one by one first, like this one, for example. Okay, I, J, and P, and coverage distance first, because it's easy. I, J, P, and coverage distance. If I equals, okay, this one, let me show you. Before we add plus there, so we put here, if I equals 1, yeah, because this one, the first line here, then I will need to save it in I equals integer dot parse. So why I need to parse it? Because in C#, the first they will read it as a string in that one line dot to string. Actually, it's not necessary because it's already string. Then you can parse it from one different variable type to another different variable type. In this case, we convert from string to integer and save it in I. What will happen if I don't do like that? Just line like this. Of course, it is error. You can see here because we cannot implicitly convert. You see the error from string to integer because you have string here as a line, but you have integer. You want to save a string as an integer. It doesn't match with the data type. But for Python, I think this has no problem because they help you to translate directly. But for C#, you need to really strict with those kind of rules. So you need to parse it by yourself. Okay, and then the rest, I will do the same. I have J, for 3 will be equals to P and stuff. This one actually not necessary. This one also not necessary. And then also this one. Okay, so I, J, P, and coverage distance nicely converted to our data here. Okay, to make sure we can always run it. You can see, click run here. Run. Okay, here you go. We display all the data still, but actually the additional code here let us to save the variable here. You can see variable I now have the value of 6, variable J now have value of 6, P equal 3, coverage distance is equal 9. Okay, and then yeah, that's all. So the rest not yet. The rest we will do next. Okay. Okay, now next perhaps A. Okay, now if you can see here, okay, this A until F has the same pattern, double like this. A, B, there is two data here. So I need to collect that one different way with the previous, this one. So I need to see that, okay, this one means that will be equals I greater than 5, but it less than I plus 1. Okay, this one. And then because it's like this. This is 1, 2, 3, 4. Okay. For this one, A until F is 5, 6, 7, 8, 9, 10. Yeah? So I greater than 5 here until I less than I plus 5. So 5 until 10. Why do I do it like that? Because it's a programs. Later on, when you have the number of I, number of 6, this one, sorry, yeah, the number of 5, I is more than 6. Let's say you change this one to 7. It means that, sorry, not this one, but this one, 7 or 10. So you may have this one more than F. So you have 5 more like this. If you have more like this, I don't really have to change my code. That's why I do it like this. Okay. Now I confused what is it before 6. Yeah. Okay, now let's continue. So now I need to have another variable, additional variable to help me to save this one. I call this one data. I put it in here, I guess that's fine. Yeah, here is fine. Okay, and then data will what? Do data, where is it? It's here, right? Data will first, because we have, this is one line, right? One line consists of 2 data. So I need to split it. Split become 2 data, the first one and then the second one. Okay. So after I split that one, there I can have this. Okay. Okay. The first one is actually to populate this one, A, B, C, D, E, F. It's populating the the customer name here, but customer name is a list, so I have to do instantiation first. Customer list equals new list. Okay, before later I can use it here as the customer name. Yeah, this one is the customer name. A dot add, it means like you can add a data there. Yeah, dot add, and then it's here is the data index of 0. Okay. And then the next, then we can save the demand here. Demand also need to, because it's a list also, so we need to instantiate it first. And then here will be demand dot add, because this one is 1, but this is not a string, so you need to parse. Okay, parse it. Okay, then you have these variables being mapped to the customer name and the demand. Okay. Next, data demand already. Okay, now the facility. Okay. The facility. Okay, here you go. Yeah, it's just continue the same way. Read data, facility name, but don't forget to instantiate it here. Okay, and you will have this data and demand and facility. Okay, we deal with all the first data here. Let's see how it goes. Okay, now you can see that customer name, okay, customer demand is 10, 8, 22, 18, 7, 55. Yeah, it works. Name, A, B, C, D, E, F. It works. Facility names, same way. Yeah, all it works. Now, okay, last one. How do you read this two-dimensional array? For two-dimensional array, of course, we need to have a little bit different treatment. Yeah, first, of course, the same way. We need to check the range here. The range I already calculated. It will be like this. Okay. Okay. Now for each of the line here, we need to how to say, separate it one by one. Yeah. So I need another auxiliary variables, additional variables. I call index I and index j to help me map it correctly in the distance matrix. And then after that, I will use these variables IDI and IDJ. First, when we have IDI equal 0, it means we need to renew, map the how many metrics we are going to solve. This one is doubles with data type of doubles, the distance. The amount of the array is I and j, because here 6 and 6, right? 6 multiplied by 6. And then we need to do the data splitting same way. But for now, for the next one, we need to have another loop here. Yeah, another loop, because here previously we have only 2 like this, right? This is the index 0, index 1. But for this one, index 0, index 1, 2, 3, 4, 5. It really depends on how big is the I and j. Okay, so the way I save it here is I create another loops, and then I will save the data in distance ij like this. Okay, and then here don't forget to add the index id I plus. Okay, and then IDI, yeah, that's it. Now you can see that all the data should be mapped already. See, distance 6 multiplied by 6, 0 to 0 is 0, 0 to 1 is 8, 0 to 2 is 15. 0 means facility A, customer 0 in the next one means customer A. Okay, 0 to 1 means from facility A to customer B, the distance is 8. It's exactly like this, exactly like what we have. Okay, those are all the reading data. So the input is already being processed well. So we already have this data, we already have it in our programs. Okay, by using this one function. Okay. Next, what we need to do, we need to process them. We just read this one. We are not doing anything yet, right? So the next things, the second step is after you read the input, okay, and then you process those input. Then we should go back again to see how do we process the input? Yeah, of course, using the greedy algorithms that we studied earlier. This one. Yeah. Okay, there is 3 steps here. Let me write it to you again. Okay, this one. I think I will make it full screen again. Okay. I normally do it like this. Let me show you. Okay, this is read data. Okay. After read data, there is one things we need to do actually before process those input. We need to have the coverage distance matrix. This one. We only have the distance. We don't have the distance metric yet. Okay. Sorry, coverage metric yet. So I create another procedure. Calculate distance matrix. Yeah. Okay. And then create another yeah, here. And okay, how do I create this one? Of course, first I need to set the array first. Coverage distance will be the size of the array will be 2-dimensional array that is as large as I multiplied by j. Okay, and then how do I fill this one? So I will convert, like I mentioned earlier. If the distance from I to j is less than the coverage distance, it will value 1 because it means it's covered by the facility. But if not, it will indicate it by 0. Okay, so we need to do double looping here for integer I equals 0, I less than I plus plus, and then for j equals 0, j less than should be j plus plus, and then if, okay, if the distance, we have the variable distance, right, from I to j is less than equals the coverage distance, then you need to do coverage matrix from I to j is equal to 1. But otherwise, else, the coverage matrix will be from I to j will be 0. Yeah, that's how do you calculate the not distance metric, calculate coverage matrix. Coverage matrix. And this one also coverage matrix. Done. Okay. Now, next after you let's check it out. What happened? Okay. Yeah. It's running. Where does it stop? Build, fail. No, succeed. Okay. Yeah, okay lah. Oh, no, no, not now, not now. I don't need it now. Later. Okay, run again. Okay, now it works. Perhaps it's the internet because I put it in the Dropbox and it's crashed a little bit. Free data already fine. And then, what? Read data. Okay. What happened? Why it takes so long? It's just line of code. Should be okay. Okay. Run. Okay. F5. Okay. It's already in this tab. When we do the calculate matrix, it will go here. Okay. And after you finish all this process, you will get the, here you go, all the same matrix actually, but instead of the number of the distance, you will have one for the distance that is less than coverage distance. It means that it's covered, and 0 if it is mean that it's not covered. Okay, that's coverage matrix. Okay, next, what should you do? Now we go to the processing. There is 3 steps I mentioned earlier, 4 actually, right? Including the greedy, the greedy adding has 4 process. Okay, let's say greedy adding start here. Okay, and then and maybe I'm not sure here. Okay, there is 3 steps. Step 1 is, here you go. Find the candidate site that cover the most uncovered demands. Okay, where is it? This one. Find the candidate site that covered the most uncovered demand. Okay, and then step 2, locate the facility there. Okay, yeah, and then step 3 is remove all the demands that is associated with that facility. And then step 4, have check if P number of site had already located or all the demand is being covered. So those are the 4 steps that we need to implement here. Okay, we will do it one by one to make it easier. First, we just do this one first. Find the located, the candidate site that cover most uncovered demand. Okay, okay. To do this, you can see, you can go back again to the example. We need to make something like this, right? Some tables like this. We have candidate facility, how many demand it's covered, and then we want to find which one have the most total demand. Okay, total demand uncovered. Okay, so we need additional variables there, where additional variable works here. Okay, for that one, I will save the total demand being covered by each particles, each nodes in this list. For example, in this table, the first one, yeah, 18, 36, 29, 26, 29, 55. Okay, so this list will have the value of, let's say I put it here, example, total demand coverage will be equals to, okay, A will be 18, and then 36, and then 29, and then 26, and then 29, and then 55, like that. So this one, I will use this variable to be utilized in here in the finding candidate. Yeah. So to make it more clean, I separate another function. Calculate total demand coverage. Okay, like that. And then since this one no implementation yet, so it will be error, and then we put the implementation here. Yes, this one. For this calculate demand coverage, what should we do? We will use this total demand coverage. Okay, total demand coverage data. Okay, and the total demand coverage, of course, we need to new it first to instantiate it. When we should instantiate this list, of course, whenever we have the complete data already, right? So to do this, okay, I think when we read data, when we finish the read data, I think we can implement this by here after this one, but before that. Okay, so here total demand coverage, normally we will do it like only like this, right? New list, something like that. It's an empty list here, but what we want actually for the first time, it will have zeros, right? It will be 0 0 0 0 0 0 like that. So I put an initiation of new double j. It's to show that will be the value, the default value will be 0 as large as 6 data or j amount of data. Okay, so we go back. We want to calculate these tables, yeah, but represented in lists like this. Okay. Total demand coverage. Okay, total demand coverage. Here you go. Let's implement it. So first, to check whether demand is covered or not, we will utilize the coverage metric, right? We have coverage metric equal to 1 if the node is covered, but 0 if it's not covered, right? So for the first time, the easiest way to do is like for integer for each facility. So for all j, right? For j, okay, we check all the facility. Okay, facility, we set the total demand coverage will be 0 first. Okay, and then we will populate. Okay, we will populate. We will check all the demand that is connected to that particular facility. Okay, how do we check that one? Okay, this one, we need to calculate if it is under the coverage area or represented by the cover matrix. So if coverage metric I to j equal to 1, then we will have the total demand coverage will be accumulated with the demand which in I, because it's covered, right? So the total demand coverage later on will help you to collect this one. Okay. Yeah, that's how you calculate it. Okay, and then now let's check. Let's try this in the first iteration. We will see whether the total demand coverage showing us the correct number already or not. Okay, here calculate total demand coverage, go to this function and then go deep inside and then finish. You see here the total demand coverage 18, 36, 29, 26, 29, 55. Exactly the same with first time we have here, right? Okay, so the first step to calculate, not yet finished. We need to find. We just calculate. We don't check which one is the minimum yet. So we have the data now. We already calculated. Now we need to check which one has the minimum total demand. Okay. Sorry, maximum total demand coverage. Okay. So to do that, to find to select which one has we will select the one that has minimum total coverage, right? This one we will select. Okay, find that has the most. Okay, I know we already have the data. Now we just need to locate and then remove all the demand covered from that one. Okay. How do we do that? Okay. We need to have another function. For this one, I kind of combine these 2 and 3 steps. Select the facility and directly remove it. And I'm not literally delete it. I just make some how to say, some variable to notice that if this is already covered, I put one variable to display that it's already covered. And again, the way you code, it's really it's coding is the way you think. Okay, so for you, maybe the way like this is a little bit difficult, so you can find a way you implement it by yourself, as long as it's already according to the procedure of the greedy adding. That's all. Okay. Okay, for me, I will combine the second and 3 step. Okay, select and directly remove. Okay. For select and remove, I need to have another additional variables. Okay, so I create a variables to note which node already being covered or which demand already being covered. Okay, so I call it node covered. It will a flag that show customer I, element I is covered by the current allocation of facility. For example, in the first iteration, when I select F at the time, right? I select the most covered demand. At first, I will have no nodes are being covered. It's represented by 0 like this. Node A not yet covered, node B, node C, node E, node E, node F, all is not yet covered. In the first iteration, when I select F is being covered, then I will change this one become 1. Something like that. So that's how I use these variables. And then we also need to, yeah, I think that one for this part. And then we continue to implement this. Select all the facility. Okay, how should I do this? First, I need another function in C#. We can find the facility with largest demand coverage. Now we know the first we need to find what is the maximum demand coverage. It is based on the table or the list that we have total demand coverage. To find which the amount that has maximum demand, we just select dot max. But sometimes it doesn't directly work like this. You need to import something. It's called linQ. linQ is a helper only in C#. Okay, so this one is applied only in C#. Okay, then this will be returned to you the number that has maximum demand coverage, in which here is 55. Then you not only need the maximum demand, but you need the index. In which index Index 0 means facility A, index 1 means facility B, until index 5 means facility F. So index here, we want to find what? Find the total demand coverage dot index of, you find the index that has the max demand curve that we already got earlier. This one. Okay. Yeah. Now, if the index is not equal -1, why is it -1? Okay. When you create this one, yeah, you see, it will search and return the object that you want. But if it not contain the object that you want or object you search, it will return -1. Okay, so if it is not equal to -1, yeah, we will continue the process. Okay, but if it is equal -1, it means it doesn't work. We cannot update the data. Okay, here here I will use another variables that we used earlier, and also one more variables to introduce one more variables to notes that whether our facility already selected or not. Okay, so here node covered, I will have facility selected. Okay, facility selected, the value will be like if you select facility F, yeah, you put 1 here. Okay, and then we also need another variables to denote how many facility already selected. And then we need to have Boolean variables to denote whether all facility already all demand already covered or not. Okay, and then next we go back to this one. When we want to select and remove the demand, we are not literally will remove it. So when you found the maximum demand, right, you go here. Okay, we will use this one, the facility selected. We will note it, the index is equal to 1, so it's selected. Select the facility. This is the second step, right? So next you need to remove. Okay, remove, step 3. But I'm not removing it, I'm giving the flag. Okay, if we know that the demand coverage matrix is equal to 1 between the customer I and then the facility that is represented here by the IDX, then we put if it is equal 1, it means that it can be covered. So the node covered I will be updated. Okay, so you will here like this one. Okay, this one not covered, it will keep 0. But if it is covered, it will change from 0 to 1 using this one. Okay. Okay, then we increment the number of facility being selected. Okay, and then here we need to update the way we select the facility later. So the demand that is being populated, demand coverage, only the one that is not yet covered. Okay, we put this one is equal 0 because this one. Okay, and don't forget we are not yet instantiate these two variables, so we need to go to the read data. Yeah, put it something like this, the same way. So we need to put here like this. Okay, now the step 1, step 2 and 3, I think it's already okay. Okay, let's check it out. First, step 1 is here, and then here you will have this, yeah, 18, 36, 29, 36, 29, 55. We will select 55. Okay, to select 55, we go here to the next part of it. Yeah, select and remove. Hop, we have 55 is the demand, the maximum demand. It is in the index 5. So you will put the here facility index 5 is equal 1. It means that it is selected. And then we will update. Okay, which one is also covered by 55? Oh, facility. Oh, it's actually only itself. So this one will be called 1. Okay, then we finish the second and then third step. Okay, now what should we do? Okay, according to this one, after the 1, 2, 3, step number 4, check whether it's already covered or not. And then if it is already covered, then okay. So we will do that one. We will do the step 4. Okay, step 4. To do the step 4, we need to sorry, all covered. Okay. Wait. First, okay, all covered. Okay, all covered. First, we need to set it equals false. False. Okay. Here, node covered. Okay. Select. Yeah. Okay. So here for the step 4, there is 2 things actually need to be checked. Have we select p number of site? Okay, that one first, and then the second one is to check whether all node is already covered or not. Yeah. Okay. Now to do that, we need to the first one, have p site has been located. Actually, we already check it here. When we increment the, where is it? This side. Select the facility. Okay, sorry. It's mute already. It's still mute. Okay. So again, we are on the fourth step. Okay. Fourth step is about how we will check whether all the facility is being open or all the capacity for opening facility already fulfilled. We check from the total facility selected. And then we check also is all the node already covered or yet or not. So the first one, we already do this in the third step. Yeah, third step here. It's here. We always add the total facility selected whenever we add new facility. So this checking is done. The one that is not yet checked is whether all the node already covered. The node covered is represented by this variable, node covered I, right? And then if all the node covered I is equal to 1, it means that all covered is true. But if one of them is equal 0, then we make it become false and then it's finished. Then we know that it's not yet all covered. Okay, we do this step. We have step 1, step 2, step 3, step 4. Then we finish the greedy adding. Okay, then you can do checking. Okay, we will do first step here. Maybe okay, to make it easier, maybe I will create a function to print the result. Print result. Okay, here you go. Let me just copy this perhaps from the previous implementation. Okay, here you go. Maybe we don't have this one yet. Total demand. Okay. Yeah. So let's print the result time to time here. Every line of the iteration. Okay. Yeah. Okay, this one just skip. Okay, this one also skip. Okay, the first step you can see here. Here you go. On the first step, first step here, we select one facility. Facility is F, total demand is 55. Then we check whether how many facilities selected, only one, it's still less than 3, yes, you can still continue. Or is it covered all already? No, it's still not yet all covered. So you go again, step 1, step 2, and 3 here combine, and then print the result. Okay, we go back here, and then here, and here. Yeah, let me see, where is it? Wait, where's it goes? Something wrong. Let me check. Let's take out this one, all of this first. See how does it works. Something wrong. Wait. Here, first iteration. No, I think there is error with the compiler again. I think with the Dropbox. Maybe next time I will not put it in the Dropbox. Let's close this and move it out from Dropbox. Yes, that's the problem. Just put it in, let's say here. Okay. Okay. Should have no problem. Okay. Let's do it again. Yeah. 1, 2, 3, 4. Okay. Next. Okay. Next. 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 Okay. The first iteration, good. 1, F is selected, 55. Next. Here you go. You will. Okay, the next one, when we calculate all demand coverage, you can see here. Demand coverage, all demand coverage here. You see, F is now 0 because it's already covered. Only among the rest is considered. So we will select B here, index 1. Okay. You can see here, the facility, the next one is selected is here, B, yeah, and 5. Yeah, when we print it, it will looks like this. Yeah. Why it doesn't print? The printing has error. Let me check the second iteration. What happened? Why it took so long? Maybe let me stop it first. Build solution. That's fine. Works. Yeah, perhaps the debugging part doesn't work well. Let's close it again. Open again. debug, disable. Let's try not to use it. And then build. Okay, now let's just run it first. Okay, you see, yeah, it's supposed to be work like this. Perhaps the debugging part has some error. The first iteration you can see here, you have 1 selected, totally minus 55. The second iteration, you will select 2, the second one, which is B, yeah, and then F still selected, 91. And then the third one, the third time you select 3, and then you get A, B, C, and then F. All the 120. Yeah, that's exactly how it works. Okay, so I guess that's the how do we implement greedy adding? Well, actually, the greedy adding is not. It's as I explained earlier. The greedy adding part is actually good for solving larger size of problems. When you have more than maybe 1,000 facility need to be candidate facility need to be selected, this perhaps can work. But still, there is a problem with these greedy adding algorithms. Okay, let's just see from this one, the simple example. If you see this simple example, okay, we consider the same problem. This problem, we have A connected to B, connected to C, connected to D, connected to E. We have how to say, there is coverage distance is 9, and this table show you the first table that we need to create to calculate all the PMAN covered, right? Based on this, you will select C actually, right? 21, because it's the largest. It has the largest coverage. Okay, C. And then after that, okay, let's select C. C is selected. Okay. And then the second facility after C, yeah, sorry, C will be covered B and B, C, and D. Okay, so when you select C, you actually select B, C, and D. Right? It's already covered. And then later, after one of these is selected, then this one is disregarded, right? B, C, and D, right? You have A and E. You have no choice here, because later on you need to select whether E or sorry, B, C, and D. No, B, C, yeah, B, C, and D, and then you need to select whether A or E, right? A here or E here. You cannot select only one and then get both, right? So you need to open 3 facility to cover all the demands. Yeah. Okay. But actually, if you can do more strategic, yeah, you actually can select B. Okay. Select B, and then select D. You only need 2 facility to open all those, to select all those demands, right? Instead of 3 using greedy algorithm. That's why this greedy algorithm is not perfect. It even say that it's far from good. So you need to have another approach to improve it. One of them is known as substitution algorithms. That is belong to a local search or heuristic algorithm. So you try to improve from what you already have in greedy algorithms. Okay, greedy adding, and then like this one is the greedy adding part. And then this one, you see, there is an improvement here. Instead of you only locate and then update, you now need to perform the substitution algorithm after you locate, yeah, to see whether it can be improved or not. Okay, And then how does it works? Okay, I will not explain in detail, but basically it just try to substitute one facility with another facility one by one and then find the best improvement that they can find. Okay, yeah. And then this is like the end of last week should be, but I think it's not enough for the time for last week. So we stop it here. I'm not hoping you to understand it directly for today, but since we're recording this, I hope you can see again. If you are going to use this type of algorithms, you can see again the implementation. I can also send you the code for this one. Okay, maybe I stop the recording here first.